In C++, STL algorithms are generic or templated functions belonging to the standard template library. These algorithms are for performing common or standard operations on a sequence of objects. Examples of such operations would be counting, searching, sorting, comparing, rearranging, transforming, etc. Being templated functions, they can work with containers such as array, vector, list, dequeue, forward list, and also with container adapters such as stack, queue, and priority queue. These functions rely on the iterators to access the container objects. Therefore, a container for which these algorithms are used must support the use of iterator, which is a kind of pointer to that can be used to point to the elements of the this containers. The STL algorithms are available through these libraries: algorithm library, numeric library, execution library. Algorithm library contains most of STL algorithms. Numeric library contains numeric type STL algorithms. They are designed to work on numeric sequences. Execution library contains the versions of STL algorithms designed to consider something called execution policies for specifying the execution mode, which can be sequential, parallel, vectorized, etc. This is more related to multi-threading topic, so it will be discussed in one of our future recordings. Here I will focus on algorithm library, which actually provides us with two or three categories of algorithms depending on how you see it. Query is a category of algorithm that examine the elements or objects of a container and return information about them without modifying the data. Mutator algorithms modify the container's data. Manipulators perform some special operations such as sorting or merging in addition to mutating. Manipulator can also be considered as a kind of mutator type. Let us talk about query algorithms. These are presumably the most commonly used query type STL algorithms. For each, all of, any of, none of, count, count if, find, find if not, adjacent find, equal, mismatch, is sorted, is partitioned, binary search. Now let us do coding exercise for these algorithms. For each, all of, any of, and none of. I have this code to start with. I will be talking these algorithms. All of, any of, and of, none of. So to work with these algorithms, we need to get prepared first. Uh, we need to have a container containing the data. So let us first create a um, I'm going to be using vector container, so you need to include vector to use vector container. So with this you are able to create a container using this syntax, and you put type here. If you want to store integer type data, integer. If you want to store integer pointer data, integer pointer. So but in this case I want to use something called person, user defined objects in it. And for this I need to create a type, a person type. I'm going to be creating this as a structure, and which has a ID and string type name, and age also integer. And to facilitate the display of the object, I want to have a friend function insertion operator, name of the object OS, and then it receives a constant portion reference, call it P. So ideally you would declare this as a friend and you define outside, but it's also possible that you can define here. So here I'm going to be using this object to display the information p.id comma p.name comma p.age, and I also want to put include this information inside something like curly brace, right? And I would be returning this because this entire expression will return voice object, so return this object because we have a return type voice stream. And yeah, this much. Now with this we are able to create the person vector container, and this is empty container. We want to include the data into it. Use push back person object, and with id let's say 3, name Alexander, as 22. Push another object with id 1, name Bobby, 20. Right, so first I want to make sure that I'm able to display the data because we have this display function. So let me have a code to display the data. For const reference maybe called person object PO, and this is the range based for loop persons, and you use PO. And since this returns so OS object, so we can also insert a new line. So let me make sure that we didn't have problem with this code, then we can go ahead from there. So I'm switching to the terminal, and in the terminal I am running the code g++ std equals to I want to use 17 standard. Output is going to main.exe, and main.cpp is a source file. So looks like there is no compilation issues. We have a main.exe. Now it is displayed without issue, right? So it looks like the code is working. Now maybe I should probably have a function, let's say something like this, so that I can continue calling. I don't need to continue writing this code again and again. So one function, let's say print vector or print container. Let me call this print container. I receive a person type object, call it persons, and for maybe I can put this code here. then call this function print c portions. So I want to make sure that I didn't have this problem with these changes. Quickly compilation execution, right? So no problem there. Now what I'm going to be doing here is to demonstrate the use of this function for each. This is a function that is kind of a generic type. You can use this function for doing anything. This function typically this is a query type because this function is not designed to make any changes to the containers, but depending on how you actually call it, it may happen to change the data, right? But in this case I am going to be using this for each to display the data first. So if I want to display the container data, maybe let me container data I can use for each. And to use this algorithm, you need to include the library called algorithm. This will make this for each available in your code. The way this is designed is that you need to pass iterator, first iterator and the second iterator, and you actually pass the function that you want to apply on each object here. So first iterator and iterator it could be the first iterator pointing to the first element of the object, first object of the container, or it could be iterator pointing to some other objects of the container. But we have only 3 objects, so I think it makes sense here to start with the first object. So we can get this iterator pointing to first object by calling the function called begin through this object persons, and the last iterator or iterator after the last end. And here you specify what you want to do with the objects, right? For example, if I want to have, let's say, a function to print an object, instead of having this, I want to have a function print which receives a constant person reference, and it actually does this thing. The task of printing it, and we can also call that function from here, print po. So we have this function, and we can use this function to pass here, pass a print function. So what this will do is, let me make a small change here. Just when you display this data together, then it could be confusing to see the difference, to identify which line was printed by this invocation, which was printed by this invocation. So just to make it look different, I'm making this function return OSTream object, and I would be returning, let's say, cout. So with this I am able to insert a new line character here, and after that here also. So let's see what this for each does. I'm switching to the terminal. First make sure that I save the file to the terminal. So now it is doing the same thing. It is displaying the data one by one, one at a time. right? What it actually it is doing is it is doing this operation for each of the element of this container from beginning to end. That means this operation is displaying the data, right? So it is applying that operation of displaying data to the first element, first object, and then second object and third object. That is what it is doing. This function can also be I mean, you can also use a function object, or you can also use a lambda expression in this place. For example, if you can create function object out of this print, you can make some changes like this. Maybe class, call this print, and you can put this inside in the public space, obviously, and change this to like function overloading operator. Right, so with this you are able to, I mean, you can use this like this. If you want to use this function object, then you need to call it differently. Create an object and then use that, treat that object as a function, and here also you can pass a function object, right? You are actually passing the function object here. So let's see in the output. So it's doing the same thing. And let me also demonstrate the use of lambda expression. So if you want to have a lambda expression doing the same job, then I would be doing something like this. You can place a lambda expression in this place directly, or you can have a lambda expression created. I mean, lamb print, let me call this equals to and you want to actually, you want this I mean, the logic is going to kind of pretty much similar to what we have here. This is a parameter, and you want to put this everything inside. Just remember, we are using this cout object, but we don't need to capture this. We don't need to print in this place, because this is not the object that is defined in the host scope, or the scope that actually includes this lambda expression. Now I can pass lamb print, and run the same code. So we have the same thing happening here, and also you can place entire this expression directly. So this is the lambda expression that is created, defined in this place, and it is directly passed as an argument to the function. This is just a warning I'm going to be ignoring, because warning is that we have not used this the variable lambda expression, name of the lambda expression that is created. So it is doing the same thing, right? Now you can also use this for is to make some changes to the data. For example, if you want to, let's say, change the name to uppercase, then something like this. So if you want to make changes, then you cannot make it constant like this. You need to allow this lambda expression when it is applied. You need to allow this to make changes. So this cannot be constant, or in this case also this cannot be constant, or also if you are using the function, you need to remove constant here. So here we are going to have function reference p, and then if you want to make all the names change to uppercase, for example this all these characters to uppercase, then you can do something like this. P, maybe you can use for each range based for loop auto and C equals to right. So then after that you can we can use this function. We can call this function again and see what happens. So I think there was a small typo issue. Let me go back and try to fix it. This is 2 upper. So now you can see all the names, the characters have been changed to uppercase. So the main point here is that you can use this as a query, or if based on how you design it, it may also make changes to the objects. So for the moment I'm going to be commenting this out because I don't want this change here. So next I'm going to be talking another algorithm which is all of. So all of is an algorithm which actually checks all the elements of the container and sees whether a condition is satisfied, uh, right? Condition specified condition is satisfied in all of the elements or not. It actually obviously returns a boolean type, either true or false. So for example, you can use all of for example, if you want to see, let's say you want to check whether all of the person object are of are younger than 25 years. If you want to do that, then you can use all of, and it is going to return something. You want to store that return value in some variable, call it result. Then again you follow the same process you did here. Start from the first iterator and then you actually specify here the condition that you want to satisfy. The condition you want to check whether it is satisfied for all the objects or not, right? So the condition is going to be, you check whether the age, for example, age is less than 25 or not. So you receive person object and you check, and you return the result. So after that you can display the result. For example, in this case, let me have bool alpha as well. Just to return, to display this output as either true or false. So in this case, we have all of the persons are not smaller than younger than 25 because of this age. So it should return false. It should return 0, right? So let us check that. So you can see the false displayed. And if, for example, I want to see whether all of less than 26, in this case we should get the true as output. So you can see the true displayed here. Now we want to talk another function, which is any of. Intuitively, I think it should be kind of straightforward. If this function is for checking whether all of the objects satisfy a condition, this function would be for checking whether any one of the objects satisfy the condition, right? So, but the way we use is going to be kind of same. I'm just trying to reuse. I cannot put auto in this case because this variable is already created, so there could be a problem with multiple definition, multiple names. So I'm kind of reusing it, and so in this case, whether any one of is let's say less than 25 or less than 21, or if you want to do it differently, any one has a number of character in the name smaller than, let's say, 5. So in that case you want to make some changes here. Let's say name dot length is less than 5. In this case we have one person object with a name less than 5, so I think we should get a true output. So this is the true. I encourage you to try with some different values and try to see whether you get false or not. I'm going to be talking another function which is kind of similar to this. We have all of, any of, and we have none of. I'm reusing the same code and only changing the name of the function. Now in this case I should get if I don't make any changes, then I should get false in this case, because none of satisfy this condition, which is not true. There is at least one which actually returns true in this case, for this lambda expression. So this is false. Now let me demonstrate how to use these algorithms: count, count if, find if not, and adjacent find. So I have this code to begin with. This was the code outcome from the previous exercise. We need vector to use vector container. We need this library algorithm to use these algorithms, and this is a person type, and the print function as a function object to be used, and this is a function. This is a function to actually receive a container and display the container. And we have a container created, vector created, and it is inserted with 3 items into it, and this is the function invocation to display the container object data. Now I am going to be demonstrating the use of count. So this is a function. It will return, obviously, I mean it will return, I think there's one type of COUNT, it should be count, and it will return the value count, either 1 2 3 4, something like that. So and I think it makes sense to store this in integer or unsigned integer, call it CNT, and or you can also call return value, and uh, we pass the first iterator, iterator as a first argument, or first iterator, or the iterator from where we want to begin as a first argument, and the last iterator. Now here we want to specify what we want to count. If I just want to count, let's say, an object like this, how many this object is available, and you can put this, and you can display that count value. But one problem here is that this algorithm requires you to be able to I mean this algorithm requires this type to be able to compare using this operator, relational operator, this operator, because it actually does compare this object with all the objects of the container. So for that we need to have this operation enabled for the type. Otherwise if I compile like this, it will run into an error. It will give the error. So we need to have that operator enabled here in this type. For example, obviously if you overload this operator, the result or the thing that is returned is going to be Boolean type, and it is I mean sensible to make it constant query type, and you receive you compare one object with another object, so make it constant person reference p object. Then what you want to return, what you want to compare. If you want to compare all this id, string, name, and s, then you can do something like this: id equals to p dot id, and name equals to p dot name, and as equals to p dot as. Or if you want to compare, let's say, as with respect to as, or with respect to name, or with respect to id, then you can modify accordingly this entire expression. So in this case we are comparing with respect to all things, so that in this case it will be counted, this thing will be counted as 1. It should return 1 because there's only one object that matches all this data, I mean id, name, and 20. Let's see whether that is exactly we can see here or not. It is complaining. I think I should have used double equal operator there. So there was a small typo. Invalid operands. Oh, I think there is another typo. Let me go back and fix it. So we have, should be COUT, not count. So the return value is 1 because we have only one object, right? But if we change the criteria for the comparison, then we can get different result. For example, if I want to only compare with respect to, let's say, the edge, then in that case I would be doing something like this. Comment this out and only compare the edge. And if we have multiple items with the same value, let's say 20, then we'll get 2 in this case, because the comparison is done only for the S data, right? We have a 2 value. Sometimes it could be inconvenient to because if you look in this if you are interested to compare with respect to only one data, then it becomes redundant, or could be not pleasing to have entire object created. So in that case we can use another version of this count function, which is count if. So in that case you provide here something called predicate, something like the function that we used lambda expression or some function object I demonstrated in the previous exercises. So this is called predicate because if this actually returns this entire this lambda expression returns true or false depending on upon the satisfaction of the condition. If we want to count the person object which has age equals to 20, then you have a parameter person object called p or po, and you return p dot age equals to 20. Or if you want to count the persons with age greater than 20, for example, if I have, let's say, it's 23 or more than 20, then you can do this, and in this case obviously we will get the value 2. So the value is 2 now because we changed the data, so the previous value is now 1, now the new value is 2. And also if you want to do it a little bit differently, for example, if I want to count number of objects which have either the number of characters in the name more than 5 or less than 5, not equals to 5, right? So in that case you can do something like this. length not equals to 5, or if it is a range, then maybe length is less than 5 or greater than 6, right? So in this case, this had to be selected, and I think this should also be selected. 2, the count should be 2 in this case. I think there was a typo problem. Let me go back and try to fix it. So we have this should be P, not S. P dot name. P dot name. Right, so we have the value 2 now. Now again, here this was the condition that is satisfied. I mean, if this condition is not satisfied, then it will find. In the first case, the name Alexander has more than 4 characters, so obviously this condition is not satisfied. Therefore, it actually found out the first object as a found object. Now finally I will talk about find and find if. We talked about count and count if. Count if, find if, and find if not as well. And next algorithm I'm going to be talking is adjacent find. And this is the algorithm for finding the duplicate, whether there is one duplicate object sitting adjacent to one object, or call it adjacent duplicate. So let me this also returns the iterator, so I can reuse this variable read val2. We have this things, right? So let me first check whether it finds something or not here. Adjacent duplicate. So it says not found, so there is no adjacent duplicate. But if we make a small change, um, let's say maybe here, uh, I want to add another object, let's say 4 and some and 20. So in this case, this is going to be these two are going to be adjacent duplicate. Okay, and so now it found that duplicate, right? But what happens if it's not adjacent? Let's see. So if I instead of having this, because it is found because this comparison, it uses comparison operator, and in our logic again, it only compares s, so that's why it is actually it has found this as a duplicate. And if I put this duplicate not adjacent, maybe put afterwards, and see what happens. So it is not found, right? If that duplicate happens to be adjacent, then it will find, otherwise it will not find. And again, you can also have a condition specified here, instead of just relying on the comparison operator of the type, like this. You can have your own condition for comparison with this adjacent find. For example, you can put that condition here, and the condition will actually in this case you need to, because it will do the comparison, so you need to have two parameters. P2, right? We have two parameters, and then you do because it will be comparing the adjacent objects. So first object and the next object comparison happens. If the first edge is less than, in this case, the um, it is not equal comparison. If you have less than p2 dot edge, then it will see whether there are two adjacent objects where the edge is first object has the edge which is smaller than second object. If you look into the data here, we have this is not object which has smaller than second object, but this is object which has smaller than second object. But if let me have this smaller at this point, so make it a bit 23, again 23, and 22 and 25. So if you do this, and then this will be the smaller than this object. So here, let's see what output we get here. So this is this data. So this is the data that was obtained. So it did find, it did compare this with this, and it was a comparison that the lambda expression returned true at this point. So it returned that pointer iterator to this object, and that was displayed by the cout statement here. Now let us learn how to use equal and mismatch STL algorithms. We again have the person type that we used in the previous previous exercise, and this is a, function. This is a function object, a functor for function object, and this is the function for printing the container. And we have a container, person container created, and the objects inserted into it, pushed into it, and this is a function that displays this data. And we will be learning how to use equal and mismatch. This is a function. Equal is a function um, to check whether both containers. It will be actually checking two containers, multiple containers, and it is for checking whether two containers are equal or not. To be more specific, to check whether two ranges. It could be two ranges from the same container, or it could be two ranges from a different container. But you have to make sure that two ranges are used. The two ranges are same. So the way you use this function is, and you provide first range, and then you provide second range. And in this case, in this case, it will actually use the comparison operator, this operator, to compare and to check whether they are equal or not, element by element. For example, if I have this this object, this vector, and if I create another vector, maybe let me create another list, not vector, list. To use a list, I need to have list library included. So for person type object, we call it plist, and maybe I can add some random data into it. I think let me add this person data into it, persons, and then I actually push back into it. So now if I want to compare this this container and this container, it could be a container of same type. You can have vector container and compare, or you can also compare vector with the list. So first the range, the iterator, and you have and then you have p list and p and this will return information that will ensure that either they are equal or not, element by element. For example, it will pick object through this iterator, it will pick object through this iterator, and it will do the comparison of the object, and then it will go to the next iterator and pick from there, compare. It will go up to this iterator, maybe just before this iterator, right? So it will return Boolean type information. So if r equal is true, you display equal. In this case, obviously you can guess that this should be equal because this list was constructed by inserting the objects from this vector. So they are equal. But if you have anything different, even one item different, for example, um, if you make, let's say, this item 0 1 2 3 persons 3 dot name, and its element 0 1 2 3 4 4. If you make it uppercase and then you test the same equality, then it's not going to be equal anymore, right? So I'm doing this, I just copied entire thing, and only change that is made between this operation and this operation is that this particular character has been set to uppercase A. 0 1 2, it should be 3, I think no, it is 0 1 2 3 4. That, I think that's okay. So let us switch to the terminal, try to see whether what we are doing is is it saying equal. Oh yeah, the reason it is showing equal is that the comparison that is done inside by this algorithm, it doesn't consider this name, it only considers age, right? So if you, instead of changing name, if age is, let's say, 25 instead of 26, then we can expect to see not equal displayed in this case. Again, I didn't I mean switch the editor. Let me just explain it one more time. So I did make just to demonstrate inequality, I did make change to this person's this object. This is object with index 0 1 2 3, so 3, and age equals to 26, just to make it different, and then apply same algorithm to check whether two um, containers, this vector container and this list container, are equal or not. In the previous case it was equal, but once I change this data s to 26, then I expect to get not equal. So they are not equal at this time. Now you can also use predicate here. Let me copy here, and at this point let me just move these things in different lines. So at this point we want to have a lambda expression predicate, and you have, let's say, in this case, if you want to compare, obviously you have to have, you're going to have two parameters. and here if you want to just compare s, then p1 dot s equals to p2 dot s. That is actually what that is actually exactly what is done by this equal. But if you want to do differently, then you can have different expression in this place. Right, again it's not equal because the data has already been changed. Next algorithm that is related to equal is mismatch. This is for finding the mismatch object. In object by object comparison. So we can use a mismatch in this way. Here call this not, maybe use let's say not equal, and it will actually return in the previous case it returned boolean type, but in this case it will return uh, iterator, so you can use that iterator to display that particular data. So if let's say not, it actually returns a pair. So it has I mean when you do comparison, I mean it actually returns a pair with the iterator pointing to the object of the first sequence or first range, and iterator pointing to the object of a second range, where at the point where the mismatch happens, right? So you can use, let's say, first is not equals to, in that case you can say that I mean in this case I mean mismatch happened, otherwise no mismatch. So this will be the iterator pointing to the that mismatch object of the first container, and this will be but to actually access the data you need to dereference this. This is an iterator, so put asterisk before. And if you want the mismatch to happen a little bit earlier than this one, then maybe we want to change, let's see, we want to make change this for not 3 or maybe for 2. Looks like I need to go back and try to fix. Yeah, maybe I think I forgot to change this function. it should be, this should be mismatch. So now this was the place where there was a mismatch, 26 and 22. This was the object from one container. This is the object from another container where there was a mismatch because of the difference in this S values. And you can also use a mismatch with the predicate like this. You can just copy paste, and I make sure that I do not forget to change this equal to mismatch this time, and not, and I want to use this if else logic. So this is also the thing that does the same comparison but with this predicate. Right, so again we have the objects that had a mismatch. Now let us learn how to use is sorted, is partitioned, and binary search algorithms. I have this code which I obtained from the previous discussion, previous exercises in this same recording. I have inclusion of vector list and algorithm libraries and person structure type with id, string, and s. And this is a function for displaying the data, and this is the function for comparing with respect to the as information only. And we have a function object, a functor for creating a function object and using it. This is a function for receiving the container and displaying it, and we have a container with some elements in it, some objects in it, and this is for displaying this data, and we have empty list created. So let's begin with this. First we learn is sorted function. Then we'll talk about is partitioned, and then we'll talk about binary search. So is sorted is checking whether this these objects are in sorted order with respect to, if you don't provide the lambda expression, then it will rely on this function to see whether they are sorted or not. I think this will require you to have another function. I will come to that in a moment. First let me show how to implement is sorted, how to check it. So the function is sorted, right, and you pass 2 iterators, and it will return a boolean value, to see whether it is sorted or not. Right, so let's see whether it is sorted or not. Obviously, I mean, it should not be sorted because 23, 23, 22, 25. So let us compile and see the false value. Yeah, now this is exactly the thing I actually wanted to come back to implement in the type in the class. So this actually when it checks the sorting, whether it is in sorted, and it need to make sure that the 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 element in the previous I mean, it keeps comparing the elements objects, and then it has to check whether the data in the previous object is smaller than the data in the next object. So we need to have this operator overloaded. So going back to the code here, operator less than, and you're going to have a constant portion p could be constant, and you return again. If you want to sort with respect to s, then less than or equal to. Let me use less than first, and then I'll come to equal to. So with this operation, and we should be able to use this function is sorted. Let's go to the terminal one more time, and we have compilation and linking, and we have execution. Now it is false. Okay. Back to the code. If I make changes so that it appears to be sorted, let's say put 22 here and 23, and here I mean, let's see whether now this current version of this objects is sorted or not. So now it is sorted, right? So this is I mean, obviously smaller than 23. 23 is smaller. I mean, smaller than equal to, and then this smaller than equals to. So this is an in an increasing order. So it is sorted. Now for each sorted, you can also I mean have the the custom comparison in through the lambda expression like we did before. You can put custom comparison here. In this case, you are actually comparing to. I mean, always you have a sorting kind of algorithm. You are actually comparing two elements, element with the next element. So you have to have two parameters in the function or expression, whatever you use here. P1, P2, and you return. This time, if you want to sort with respect to, let's say, see whether it is sorted with respect to the number of elements, number of characters in the name, then you can do something like this: p1 dot name dot length is less than p2 dot Obviously, we can expect that in this case it is going to be false. It's not sorted. So it is not sorted with respect to the length of the names. But if you have a container with name appearing in sorted order, then it could be, for example, if I push this first and this two, this at the last. In this case, we may get sorted as a true, but definitely it will not be sorted as true for in the with respect to the s, but it will be sorted as true with respect to the length or number of characters in the name. Right now it became true. Previously it was false and previous was true. Now we have previous false and the new sorted result is true. Now let us move ahead and talk about this is partitioned, and this is the function for to check whether a container is partitioned with respect to a certain condition, with respect to the object satisfying certain condition. That means if you want the objects of the container to satisfy criteria, then whether the objects satisfying that all the criteria appear in the beginning and all the objects not satisfying that criteria appear in the end, if whether it is organized that way or not, right? For example, if we have a criteria to be satisfied as, let's say, um, s equals to 23, in this case these two objects will satisfy and they are in the beginning, and these two don't satisfy, they are in the end, right? So in that case each partition should return true. So now here I can use again it will return a boolean type, so I can reuse that variable result equals to std is partition and begin and you actually need to have this thing here. In this case I mean it will check whether particular object satisfies a criteria condition or not. Therefore we are going to have only one parameter p, and we have, let's say, p dot s. I expect this statement to display true because our object is actually partitioned. Our container, actually the objects in the containers objects in the container are partitioned, or container is partitioned as with respect to satisfying this criteria. So it is false. I think I need to go back and see. Okay, I think let me go back and check s value. Yeah, I think there was a small error here. I should have used 23, not 22. So 23 So now you can see the expected outcome here. The value is true. So this is partition with respect to condition satisfied. I mean s being equals to 23. Or you can also see whether, for example, if you want to see whether the length is less than or equal to 5, and the edge is less than, let's say, 20. If you want to satisfy both criteria, edge is less than, let's say, 20, less than 24. Okay, if we have those criteria, for example, something like this, name is p dot name dot length is less than, let's say, 5, less than or equal to 5, and p dot s less than 24. If this is a criteria, in this case also it will be I mean partition, because these two objects satisfy this criteria and these two objects don't satisfy. So we have true. But if you use something different, then it will not be partition. For example, in this case, if let's say age is greater than 23, so now it is not partition. Okay, now we're going to be talking about another algorithm, binary search. This is a search algorithm which actually does the searching by dividing the container or the sequence into halves, 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 and halves. It continues dividing in halves. So, but one condition for the this algorithm to work without issue is that the container has to be already sorted in the shortened way, right? For example, because it has to be sorted. Sometimes, for example, if it's sorted returns true, then it is sensible to apply this. This binary sorts. So if you go and go back to the output, uh, I think let me go back to the code, and we had is sorted used, and it was false, right? It was not sorted, so we have to make sure that it is in sorted form. So maybe we add more data into it. Let's put it here. And we have is 1 2 3 4 and then 5, and we have 6, So we if there's any criteria that actually I mean whatever criteria we use, if that actually happens to be uh, I mean the criteria with respect to which these these objects are sorted, then we can apply binary search. Right? For example, if you want to use S criteria, then it has to be increasing order. If you want to use, let's say, the uh, this letters, this string, and I mean name, it has to be sorted. Right? For example, A, B, and then you have this M, and then S A, S A U, S H. With respect to the name, it is already sorted. So if you apply binary search in this to find a particular item, right? So let's do this. Go down. So here, binary search will actually return an you can use binary search like this std and you have again iterators, and then you want to place object that you want to search here. So if I want to search this object, I place it here, and it will return the result, and you can display the result here. I hope I have not used result. Yeah, maybe change it to a different name. So it is not able to find it. And the reason it is not able to find it is that in the binary search it uses the comparison, but the comparison we have used here is the as comparison, but it is sorted with respect to, let's say, name length. I mean with respect to the name. So that is the reason it's not sorted with respect to the s, therefore we are not it's not able to find it. Sometimes it may able to find, sometimes it may not able to find, but the behavior is not certain. But if it is sorted, then the behavior can be guaranteed. It is guaranteed it will find. For example, if we do comparison with respect to the name, for example here, instead of comparing as, if we do comparison of the name, then we will be able to find this object in the container. Still it is showing false. Oh, I think the problem is with the operations that binary search uses. It actually does the comparison. It actually needs to use both this operator, this comparison, and this comparison for the less than. So you also need to have this less than comparison carried out with respect to the name. So So with this change, let me try one more time. So we have terminal. Now it is true. Okay, now it found that particular object. You can also do you can also specify the condition criteria at the end of this last argument as a lambda expression. For example, if I want to specify the criteria to be used as a, let's say, name, then I can have a lambda expression like this, and I can use because this is going to be comparison, so you need to have a two parameters, p1 and constant p2, and then when searching what is the testing you want to do, comparison you want to do, you can you want to specify here, right? So return, let's say, p1 dot name dot length less than p2 dot name dot length. So if you do like this, then it will consider this length criteria. Then in that case it will I mean assume it is sorted with respect to length, since we don't have this sorted with respect to length. I mean, when we source different objects, let me put this different objects, we will not get correct output. So let me put this here. This is a short source object. So if we put all the options, just I want to check whether this sorting, this binary source will actually work for all the objects in the container. So we have this situation, and then I want to search for first object first. There's something missing in the core, semicolon. So it is false, it is not finding it. I think I missed one thing here. So this is not sorting with respect to the length. So it is sorting with respect to the, I mean, alphabetical character. So with respect to the characters. So I think we should have this logic here. Back to the terminal again. Try to see whether it works or not at this time. So it is true. Next, I want to source another object. So it is also true, it is found. Next object. Is also found. So true. So so it is true. All the objects are actually found. Right. So but if we do it differently, then there could be, it's not guaranteed, because if it is not sorted, then it's not guaranteed. For example, 22, 23, 25, 23, 32, it's not sorted, right? So if we do this with respect to edge, so it is false, right? It can be true for some of the elements, but the I mean correct result is not guaranteed. Let us talk about mutator algorithms. These are presumably the most commonly used mutator type STL algorithms: copy, copy if, copy n, move, fill n, transform, replace, replace if, generate, generate n, swap ranges. Let us learn how to use these algorithms. How to use these algorithms in our code: copy, copy if, copy n, and move. I have this code which I obtained from my discussion in the previous part of this recording. I have a person structure with attributes id, name, and age, and this is insertion operator to display the data. This is a comparison operator which returns true when the name are same, otherwise it returns false. And this is also comparison operator for the smallness. Again, it compares the name. This is a functor to be used as a function object. Print C function to display a container contents, and we have a vector container and we have list container created. Vector container is populated, or these objects are inserted into it, and this is a statement which is to display the content of this container objects. Here I will demonstrate how to use copy STL function. First, copy function is for copying the content data from a container to another container. So if I want to actually copy the content of this person container to the list, then either I create a list with the same size as the person, or same size as the number of person objects to be copied to it, or you can start with the empty list and follow this process. Copy function, this copy algorithm gets first argument the iterator, which from where you want to start copying. I want to copy all the objects in this container, 1 2 3 4 5 6, all the 6 objects. Therefore the iterator pointing to the first object, and the iterator pointing to the last, object. This is not actually iterator pointing to the last object, it is pointing to the thing after the last object. And where you want to copy, it's going to be plist. If you have already allocated a space in this container, in this list, then you can pass the iterator like this. If you don't have, then you can use a back inserter, so it will carry out the operation of pushback into the list. Then after that you can see the content of the list by calling printf function and passing it as a argument, right? So let us see whether these items are copied into the plist or not. Compilation and linking, and execution. So this was the data displayed from the list container, so it has been copied, all the data. Now if you want to copy certain items, the items that satisfy certain condition, in that case you can use copy if. Let me clear the list to use it again. Copy if, and you are going to have 3 arguments, same as with copy. And finally you want to have a logic here to tell copy if function to select which object to copy, which object to ignore. So this is a lambda expression receiving a person object, and you actually return true for the person satisfying the condition. For example, if I want to copy the objects with first name beginning with letter S, then I would return p dot name first letter equals to, right, and you can again print and see whether only these objects are copied or not. So this was the outcome. This was the outcome of the second copy carried out using copy if. So only the objects that satisfy the condition have been actually copied to the list container. So you can also experiment copying different criteria. For example, if I want to copy an object with let's say is less than say 20 25, less than or equal to 25. So in that case I would return less than or equal to 25. So in this case I would expect only this to be copied, this to be copied, this copied, this copied, and this two left uncopied, these two objects. So you can see these things are copied. All the objects copied they have is less than or equal to 25. Now if you want to copy a specified number of objects beginning from one particular iterator, for example from this iterator or whatever iterator you want to you want to copy let's say 5 elements or 3 elements, 3 objects after this iterator, then in that case you can use copy n. So you start from this let me just copy this 3 arguments, and you start from one iterator. Maybe if you want to let's say copy from the starting from this second object, and you want to copy 3 objects beginning from this second object, then in that case I would pass the iterator pointing to the second object, and then number of objects I want to copy is going to be 3, and again back inserter. But before that I need to clear this list. Then after that I want to again display what is, to see actually what is copied. I think I missed a semicolon. So these are the 3 items copied from this list. So beginning from second 1 to 3, right? So it is working as we expected. Finally I will talk about move function. It does move operation element by element move. Which means the dynamic memory content is actually moved instead of copying. So if I want to move let's say from the persons, let me print persons first, and I want to do move, and when I move I need to actually specify where I want to move into. So give some name, new person container, something like this, and then type let the compiler infer itself. Now after that if I display persons, and again print C. So in this case, we actually moved content from person. So before moving, we can see what is the content, the data belonging to person's container, and after moving, we'll see the data belonging to the person container, and we will also see the data belonging to this new container. I should have used persons instead of person. So we have persons. So uh, I think I should do a little bit more. I mean, add a little bit extra things, so just to make sure that the things are displayed. Okay. So if let's say if not empty, then you print, else and again we do same for this print C. If so we have empty. So let us check it. What the change I made is, if the container is empty, then it will display the data, otherwise it will display some text here. So the terminal, sorry. So now empty container. This was the content of that container, that person's container. Then when it is moved, it became empty. Container doesn't have anything, and then everything is moved to the new container. Let us learn how to use these algorithms in our coding: fill, fill-in, and transform. I have this code to begin with. As usual, I have been using this code in my previous recording. So this is the type of which object I want to include in the container, with id, name, and s, and this is a function for displaying the data, and these are for comparisons. And this is the function to display the contents of the container, and it internally uses this calls this uses function object to display the data belonging to one particular object, and this actually makes use of this functor. We have a container with the data objects pushed into it, and then displayed content and empty list container. So with this I want to demonstrate how to use fill in this container. If I have any a range of objects where I want to fill with certain different data. Or for example, if I increase I mean the size of this person's house container is 6. If I want to increase the size to, let's say, 9, I can use this function resize, and then maybe you can use 9, or you can use let's say plus 3, something like this. And after this the size will be increased, but in the increased content there's going to be nothing, empty content. So now previously the size was 6, now it is increased, but in the increased objects, the object that were added to increase the size, there's nothing. If you want to fill these objects with some specified object with specified some data, and then you can use make use of this function fill, right? You can do it like this. First you want to pass the iterator from where you want to start filling in. It's going to be and minus 3, and you want to fill up to end, and then what you want to fill with person object with id 111, name xxx, sorry, xxx, and as 0.0, right? Then after that we can display, and see what happens. Now you can see this empty objects have been filled with this object, with this data we have. Similarly, we can also use fill to, let's say, to another container. You can resize, create the size and fill with some specified object in another container. And if you want to, let's say, instead of filling this using this, if you want to beginning from one iterator, if you want to fill, let's say, next specified number of objects with the specified object to be filled in, then you can use make use of another function. Let's say, for example, in this case I want to fill, let's say, from 6 fourth object to this 4th, 5th, 6th object with something else. In that case I can use make use of this function fill n. And here you are going to be passing the iterator plus 3, I guess, 0, 1, 2, 3, and then you actually fill 3 objects by maybe different data. And let's say 333 y y y y, and then as, let's say, 199. Again I missed the character S, So now you can see these three items have been filled uh, with this the object with 333 ID and name YYYY and age 199. Now I will demonstrate the use of transform. Right here we talked about using fill n. Now I will use transform. So transform is for actually uh, transforming the data to the objects. Right. For example, if I don't want to fill here, let me comment this fill out so that I can work with this original container. So I can do some transformation to the content of this data and maybe write in this list. Right. One example of transformation would be I want to change all the characters in the name to uppercase. Or I can change this ID to, let's say, if it's 3, then I want to change it to, let's say, 1 103 101 104 102, or 1003 1001 1004 1002. Right, those are the examples of the transformation you can make in the container. So you can use this transform as follows. Again, you want to tell from where you want to start transforming. I want to start from the beginning and I want to transform until the end, and then where do you want to write the transform data. So I want to write in plist by using back inserter. Then you want to specify what kind of transformation you want to realize. So you are doing this transformation to each object, so there's only one parameter in the lambda expression, and if you want to change, let's say, the name to uppercase, then I would do something like this. Use a range based for loop. I don't want to make change because this is constant, so maybe create a new object and make change in this object. Name and s equals to return temp. So this is the object that is going to be returned, and whatever object is returned, it is going to be inserted into that list one by one. Then after that we can print plist. Right, so let us see how does this particular code behave. Expected expression, maybe I missed comma or something. Let me go back to the code and try to fix. Yeah, I missed comma here. So now you can see all the this characters have been converted to the uppercase characters. And similarly, if you want to change this number to, let's say, 3 to 503, 1 to 501, then we can do something like this. So again, in this object, p.id plus equals to 500. Well, I should have used not p, but it should be a temp object. So it's going to be temp, and yeah, on the terminal. So you can see the ID has also been transformed. So this is the way you use transform. There can be different ways you can use transform, but this is one of the thing you can do with this transform function or transform algorithm. Another example of transformation you can do would be one simple example. Suppose I have a vector container. Vector container for integer type equals to 1, 2, 3, 4, 5, and I want to apply transform to it. Bint.begin and bint.end, and the target you can transform the original container. Like in this case, we copied the transformed objects into the different container, but you can transform and rewrite the same container. In that case, the target iterator is going to be bint begin, and the transformation you want to do would be something like this. If you want to for example, if you want to do squaring of these numbers and then write replace the original number by the square numbers, then you can receive integer and then you return a square. Now you can print again. Looks like I missed a comma. Comma here. So now there's another problem. So because we have integer type, so print function object is not working. So we have integer data type. So when you call this function, then it will call, but it will send. In this case, it's a we didn't have implementation for person object, right? So maybe we can have overloaded version of this operator to display the integer type as well, or you can create a template type that will also work. Integer type. So now it is displaying the integers square. So it was a square and it was displayed 1, 4, 6, sorry, 9, 16, and 25. Okay, these are the squares of 1, 2, 3, 4, and 5. Let us learn how to use these algorithms in our coding. Replace, replace if. This is my code to begin with. As usual, we have a vector container with the objects in it, and we have some functions to display the container's data, and we have the person object. This is a type person type structure to be used as a type for the container objects. So I want to demonstrate how to use replace and replace if. This function replace is for replacing one specified object by another object. For example, I want to replace this particular object, let's say this object, by a different object, and then I can use this replace function. So I want to replace all the objects with this particular data. For example, let me create let me add another object, maybe in this position, or maybe here. So if I want to replace this object by a different object, object with different data, then I can I should tell replace algorithm to scan through all the objects, and wherever it finds that particular object, you replace with another one. So you need to start from the first iterator, and then you go up to the last iterator, and you need to tell which object you want to replace. I want to replace this particular object, and I want to replace it by another object with different data. Let's say 1 1 40. Now we can see what happens after this function invocation. So I think it is okay. Let me go back to the terminal and try to see the output. So you can see this object was being replaced. So this object and this object and this object has been replaced by this object and this object. And to use a replace if you can replace if a certain condition is satisfied. For example, you can use the replace if if you want to replace this, if provided that certain condition is actually satisfied. In that case, I don't need to specify this thing. If a certain condition is satisfied in this object, you replace. Otherwise, you don't do that and do anything, right? So I'm going to be having all these objects, all these arguments, and here instead of having this object, I want to have the logic. that actually specifies the condition. I want to replace, if let's say p dot name is equals to or maybe I want to replace back to the original name. So if it is R, and then I want to replace this to object with this data. I think this condition should satisfy to that particular object. For example, we have only R. We have replaced. I mean, only these are the only objects which will have the first character of the name as R, and then after that we print a container for this. Then we go back and try to see what is the problem. So we have I think yeah, the thing missing is return keyword here. You need to return the result of the evaluation of this expression, either true or false. So now it has been replaced back to the original name 4 with mama and 25. This object, and this object has been replaced back to this object, this object, and this object. So it is changed back to the original object by through replacement, but through the use of replace if function. Let us learn how to use these functions: generate, generate n, and swap ranges. As usual, I have this code to begin with. In my code, I have this person type with attributes ID, name, and age, and function to display the data, and for compare the objects, and this is a functor to print one pretty single object, and this is for just printing a container, entire container contents. I have a person's container and objects inserted into it or pushed into it, and I have empty container here. So I'm going to be demonstrating the use of generate, and then generate n, and then these three functions here. The purpose of this generate function is to fill the content, to fill the elements by generating. If you remember, I discussed fill function previously. this function filled the elements by a same object, but is able to generate different objects or object with different data and fill those places of specified places in the container, right? For example, if I let me create a new container, with called pvec person vector of a double size double size which is 2 times the size of person, 2 times and I want to actually fill its content. If I use fill function, then I would be filling with the same data into it. But if I want to fill with the different things, different data, then I can use a generator function. The way I use is I specify the iterator for where I want to fill, right? Beginning iterator and the end iterator. So I want to start filling from the beginning up to the size of the person. In this container, I want to fill, let's say, this 1, 2, 3, 4, 5, 6, 7, 8. 8 element to it, or 8 objects to it. So plus person size, and then you actually have a function, either function or lambda in this place, to generate the objects to be filled in, right? So let me have a capture list. How you generate, you can have a different way of generating. In this case, I consider, this generator will actually pick the objects from this container and fill in this pback container. So what I want to do is maybe I want to, because this is defined in this scope, so I want to use this person. If I want to use this person object, this object inside, then I need to capture it, and I don't have any parameters. Then I want to return person's I, but I need to have I, right? So for I, let me create a static int I equals to 0, then I plus plus. So this should actually pick, because each time this function is called, I will be incremented, and then 0, 1, 2, 3, it will pick corresponding elements, objects of this container, and return it, and that return object will be used to fill in the positions, the elements or objects of this new container pvec. So let us see, let us display the pvec vector objects data. So let me compile and execute. So now you can see this was the previous container, and we created a new container with double size, and up to the size, number of elements equals to size of the previous container, we actually filled in. But we did that through generator, but obviously generator actually did make use of this original container. It captured the container and actually it returned its elements. And if, for example, if I want to fill in the rest of the elements, because it has only half of the size filled in, half is empty. So if I want to fill the rest of the elements using different approach, for example, asking user to enter the data and then fill in, then I can do as follows. It's going to be begin plus size, and then go up to dot end. Here I'm going to have a lambda expression, but I didn't need to capture anything because I will be asking user to enter the data. So let me create a portion object, and enter ID, name, maybe with space, and then region ID, and then name, and then you return that object. So the generator will actually keep returning this object, but each time it will ask user to enter the ID, name, and s. So now afterwards we can again see what is happening to the container. Right, so switching to the terminal, clear everything, compilation, and looks like, yeah, now it is generator is being called, but it is asking me to enter the ID, right? So this whatever I enter is going to be inserted in this place, copy, and then next it will continue asking up to this point, right? So there are 8 number of entries I have to do here. Let me do it on the ID. Let me use, let's say, start from 21, and the name, I'm going to be using only 3 characters, and is 31, again 22 and 32, 23, 33, 24, 34, 25, 35, 26, 32, 27, 25, 28, again 26. Now you can see the new container. This container, previously it was these are the data I entered, but after that the container had the previous objects up to this point, I guess, and these are the newly added objects to the container. Now let me demonstrate the use of generator and this function. If you want to actually instead of specifying the begin and end, if you want to specify, let's say, number of objects you want to generate, maybe generate and append to it. So we have you want to have a way of I think, let me do like this. So this is a function generate n, and the first thing you want to pass is going to be the iterator, right? But if you want to this pvec has all the contents. You want to insert it a newly generated object at the end. If you want to, like in this case, we want to start writing from here, but the memory was already allocated, so we have begin and end, right? But if there is a memory allocated, you have to keep inserting the generated object into it. Then you can use back inserter in pvec, and you can specify the size what you want to enter. Let's say if you want to, let's say, insert maybe 5 new items, 5 into it, and the generator logic, maybe create an id. Let me see, let me pick an id, and id equals to the id of the last object of the container, int, and this is not iterated to the last object. -1 is iterated to the last object, and you want to get the id of that object, id. So it will actually pick the id of the last object, and I want to use that object. Let me capture it, and then have int x equals to id, and then create a person object, call it temp, and temp dot id equals to, let's say, x plus x, and name equals to some dummy name, oppp, temp dot as equals to, again, let's say 31 plus x minus id. So this is the way I am trying to use a generate n, and insert the generated objects into the at the end of this container pvec. So, and after that I want to actually display. So let me go to the terminal, try to execute it. Again, it is asking me the data like before. Let me have 11 and 21, 12, 22, 13, 23, 14, 24, 15, 25, 16, 26, 17, 27, 18, 28. Now these were the these were actually generated. All this data is actually generated. This is generated using a generate function by copying the content from the previous container, and these were actually created by generating from the user entered data, and these were actually generated and append it by using generate underscore and function to the container. Now finally, let me demonstrate the use of swap ranges. This is for swapping the range. For example, if I want to swap this these three elements with these three objects with some three objects from another place. It could be between two containers, or it could be between the same container, right? I'll be demonstrating swapping in the same container, in the person container, but you can create a list container and try to see swapping between this vector and this container. So the way we use this function is I'm going to be using the same container that we are using here, pvec. Three objects plus 1 2 plus 4, so it will swap three objects. The second object, because this is the iterator pointing to second object, second, third and fourth object to maybe a different position, maybe just three objects at the end. So p and minus 4. This is three objects. It will swap with swap the second, third and fourth object with the last three objects just before the last one. So after that we can also try to see the outcome, and then here so to the terminal again one more time, clear everything. So again it is asking me to enter. Let me do it. 1 1 21 1 2 22 23 24 25 26 27 28. So now we have this container. Let me it has let me just copy this thing and take to the I'm copying it into the editor so that it will be easy to analyze it. So here we have we actually attempted to swap these three items with the last three items, these three items. So you can see in the first three items, these three items have been copied in the short version, and this first three items, this ma'am, Bob and ma'am, have been copied to here, right? So this is the swapping happening within the same container. Let us talk about manipulator algorithms. Here I will focus on the following manipulator type STL algorithms, namely reverse, rotate, unique, partition, sort, and merge. Let us learn how to use these functions in our coding: reverse, rotate, and unique. I begin with this code where I have, as usual, person structure type with id, name, and age. This function for displaying the data, this function for comparing. Only name is compared. If a name is same, then in this case two objects would be considered equal. And less than comparison for only name, and a print function to display person object and integer data. Print C function to display container data, and we have person container created, and we have these elements, 1 2 3 4 5 6 7 8 9 10. We have two duplicates here, here, and here. So, and we have an empty list. So we start looking into how we can use reverse algorithm. What this algorithm does is, if you have, let's say, a list or a sequence of the objects or sequential container, then it will actually do reversal. That means the result of reversal will be, let's say, 3 2 1. Right? In this case, the result of reversal will be this will be first object and second object, third object, fourth object, fifth object, and so on. So this is very simple algorithm, but many times it can be very useful. So the way we use this function is the first iterator and the last iterator. After that, you can see whether reversal has happened or it has been reversed or not by printing the container. Let me check in the output. So you can see this was the container, original container data, and then the reversed data. You can see everything is this first last is first, and the second last is second, third last is third. So it has been reversed. One interesting application of reversal would be the string reversal. If I have a string object initialized to hello world, and a good thing about this string object is that it provides us with an iterator, so we can apply that in reverse or any STL container, STL algorithms. Right, so this will result in the reversal of this character. So this will go to the first character, and the second, third, fourth, and so on. So you can see this is the reverse string. So HELLO hello world. Next, I will talk about another algorithm, which is rotate. In the rotate, it actually does the rotation of the elements 1 2 3 4. If I have something like this, the rotation would be, if I want to rotate by one position, one step, it would be 2 3 4, and the first will go to the last. You can assume that these are the, points in a circular disc, and if you rotate, and you can see how it would look like, right? So when you rotate in this direction, this goes to the last. Sometimes this is also called as circular rotation. So a slide, the application of the algorithm is pretty much similar to rotation. You can just use the same algorithm, and similar to this reverse algorithm. You can just change the name to rotate, and after that you can check it. When I demonstrate this, I actually want to comment this out because I didn't want to start with the reverse version of the container. I want to use with the original container and see whether it rotates or not. And when we have the arguments that are provided, first we want to work with in this range, but which element you want to be the first element after rotation, you need to specify it here. If you want to rotate by one unit or one object, just +1. If you want to rotate by two objects, 2. By 3, 3 plus 3, and so it goes that way. So the result of rotation by one object would be look like something like this. Again, I missed one character. So it was the original container. Maybe let me, I think there was something missing there. Let me go back. Yeah, the thing that was missing was that I used a string as a container. I should have used persons here. So just use persons. So we have now you can see it was rotated by one step, so this went to the first position. They're shifted up, and then this object went down to the bottom. If I rotate by 2 steps or 3 steps, it would be 2-step rotation. Let's say 3. Then the third element will go to the first position, or third object will go to the first position. Right, we have this was second object went. Maybe I didn't compile properly, or maybe I didn't save the file. Let me save again and compile. Looks like it is not working. Oh yeah, I think it's this has gone to the first position, and then Sarah, and Saurav, and it went up to this point, and this 3 actually came from the top, right? So it is circular rotation. Now sometimes you may be interested not to rewrite the original container. If you want to copy the rotated version in a new different container, for example, another vector or this list, which is empty list, then you can use the same syntax. Let me just comment this out, and at the end, after comma, you can place the target container. If it is empty, then it's going to be a back inserter you want to use. Then after that, you want to see both persons and plist. Just want to make sure that we didn't have any changes made in the persons container, and the rotated version is copied in the plist. Then you go back. Looks like something is missing there. Oh, this was not necessary. No matching function. Oh, I think I missed one simple thing, important thing here. So it is not exactly this rotate function that you want to use. The name of the function that you want to use to copy the rotated version to another container is rotate underscore copy. So this is the new copied version, and this is the original container, vector container. This was the rotated container. So the first three elements are appearing here. Now I will be talking another function which is unique. This is the purpose of this function, or usefulness of this function, is to remove the redundant objects. If a container has multiple objects with the same data, then you want to actually remove. And when I say same data, it is with respect to the comparison operator, this operator. In this case, if we have two with the same name, then we want to actually remove. If you want to remove objects with the same ID, name, and age all together, then you want to change this expression. But I'm considering only name here. So we have these two objects with the same name and these two objects with the same name. So we want this to return, this object and this object. So for that, I want to apply std unique and persons dot begin, persons end, and it also returns something which is a kind of iterator. Right, so after this happens, I want to see different things. One is what is an iterator. Another thing is if it is some of the items are removed, then we want the size to be smaller. So I want to see the size of the persons, and I want to display the data. So we have, so it was this was the uh, object the iterator was pointing. Basically this is I think this, it is pointing to this object, and the size is still 10. There's no change in size because previously we had I think it's 1 2 3 4 5 6 7 8 9 10, right? So size has not been changed, but good thing is that we have this iterator pointing to that redundant data, because the objects that are to be removed have been moved to the bottom, and we have an iterator pointing to this redundant object, so we can make use of that iterator to remove these objects and reduce the size. So that is the something that you actually want to do once you actually have things removed. So now uh, since this iterator as it contains the iterator pointing to the object which is actually to be discarded, we can do we can erase those objects using the erase function that is available through the container itself, and pass iterator and erase up to the last element. And now after that I think we'll have um, the size and container reduced, right? So if we display the size, size should be reduced, and this should actually display a smaller number of objects. So to the terminal, again I didn't like this, so we have now you can see the size is reduced to 8 from 10, and those redundant or um, to be removed objects are actually removed. So we have one unique objects here. And one thing that I want to clarify here is that it will remove this unique will remove objects where the duplicates are placed consecutively, like this we have duplicate of this Sarah placed here and duplicate Sarah placed here, but if they are not consecutive, for example if I have this placed here and in that case this unique will not work as we expect. So let me check in the output. So now we have this repeated this has been sent to the end, but this has not been I mean moved to the bottom, so we cannot actually do the removal here. Let me go back just I might not have printed the data. Yeah, I printed it, so it doesn't work as properly. So to properly for this algorithm, unique algorithm to work properly, these have to be placed consecutively, and it's best to have sorted. If you have sorted container, then obviously the same object, equal object, will be placed consecutively. Then this function will work. Now let us learn how to use these algorithms in our coding: partition, sort, and merge. As usual, I have this code to begin with. I have a type person ID with the data ID, name, and s. We have a function to display the data. We have a function to do comparison, comparison for smallness, for small, and we have this functor to display the person object and integer data, and we have the print c function to display container of elements, and to display each item we actually call function object. We use function object. We have container, and objects have been pushed into it. These are the objects that are pushed, and we have empty container, list container here. So now I will talk about partition function. The purpose of this function, partition, std partition, is to rearrange the elements so that the elements or objects satisfying certain condition are placed on the left side or in the beginning of the container, and the objects not satisfying a condition are actually placed on the right side. That is the way we do partition of the container. So the earlier portion of the range or the container will contain the objects satisfying certain condition, that satisfies certain condition, and the later portion of the range will contain the objects that do not satisfy a condition. Right. For example, if I want to partition this container, so with respect to the evenness of the edge, that means I want all the objects with even value of s to be placed first, and I want all the objects with odd or not even values to be placed after that. That means I want this object and this object and this object to be placed in the beginning, and other objects to be placed after that. So that is the way of doing partitioning here in this particular case. Or you can also choose to do partitioning with respect to the number of characters. If 5 or less character to the left, others to the right, or it could be based on ID as well. So let's do it. Function partition the condition p and return. We are partitioning with respect to the evenness of s, so p dot s %2 equals to 0. This is the thing we written here. Then after that we can do printing, and see what happens to the container objects in the terminal. Again, typo issue. To begin, print C. So you can see these even number elements are placed here on the top, and then after that odd uh, the objects with odd edges 23, 25, 23, 23, 25, 31 all placed. They are not necessarily in sorted form, but they are placed as a chunk of uh, the objects with even edge value on the in the beginning part, and the chunk of the objects with odd edge value in the later part. To demonstrate it a little bit further, to make it a little bit clear, um, let me change I mean let me increase the number of elements objects with even edge value, maybe make it 24, and so Rob 20, 30, 36, and we have another repeated Sarah, say 29, and we have 1, 2, 3, 4, 4 and 5. Let me experiment with this one more time. So we have this partitioned and others appearing after that. I think I should also have changed the value for this object as well. But I think one of the things I want to demonstrate here is that if we go in sequentially, this is an even object with even edge, and then we have Bobby. If we want to maintain the order, then Bobby should have been second here, placed here, but it has been placed last, and this has been placed second, and this has been placed in the third position after partition. And here also maybe you may be able to see some reordering. For example, this is first, and then Sarah 25, 23 should be second, but it has is not 23, it's 29. So there has been the order has not been maintained in partitioning. So if you want to maintain the order, then you can do another version of this partition algorithm, which is called stable partition. So with a stable partition, let us check the output again. So you have the first item, this one, and then second is Bobby, which is in the second position, and the third item here is Saurabh with 32. Saurabh is 32, and the fourth is with 36. And for the odd partitioning also, the first item here is this one, 25, and then Sarah 23, and again 25, then we have Sarah 29, then Mama 25, and Sen 31. So order has been maintained when partitioning. So you see the difference between just a simple partition and stable partition algorithm. Next I will talk about sorting. There could be multiple versions of sorting, but I'm focusing on only one version here. So if you want to rearrange the objects with respect to some certain criteria. In this case, we have name. Then we can use sorting, but this sorting actually inherently uses by default it uses this comparisons, but you can also specify custom comparison for sorting. So first let us do the basic sorting without specifying the custom comparison. You use a sort algorithm using this syntax, and then after that we can do print and see whether the elements are sorted or not. You can see because we our comparison that is defined with the type is designed to sort with respect to the name. So it has been sorted with respect to name, Alexander, then B and M. They are same, so they are placed together, and after M comes S, and after S we have SA, and then SAU, and SH. So it has been sorted with respect to the name. But if you want to do custom sorting with respect to some different thing, which is actually not provided with the comparison, and those things not provided with the type, person, then you can use sorting using this syntax. Then after that you can specify this the function. In this case this will be different than the previously used function, because sorting always compares two elements. Sorting algorithm does compare, and if one is smaller then it does swapping. Those kind of operations are involved inside internally. So you need to have two parameters here. It doesn't make change. So in the person data, so you can have unmodifiable and the reference type P2. And if you want to sort, let's say with respect to the length of the name, number of characters in the name, then you can have P1 dot name dot length, it's going to be greater P2 dot name dot length. So it will actually sort with respect to the number of characters in the name. This is a kind of a custom specification of this condition for applying the sorting process algorithm. So you can see let me go back and see what is happening where. So I have not displayed the sorted outcome. Print C, to the terminal. Now you can see obviously it is sorted in descending order with respect to the number of characters. So you can see here. If you want to sort in the ascending order, then you just reverse the comparison operator right here. You change this to less than. So now it is sorted in ascending order of the number of characters. So as exercise, you can think of different criteria for sorting and experiment with this. Now I'll move on and discuss another function uh, which is a merge function. So merging is a process that is involved in, if you have heard about something called merge sorting in data structure courses, then merging is one of the steps that is actually involved, important or key step that is involved in that algorithm. So this algorithm can also be useful in merge sorting. So merging is a process. For example, first let me explain. Here you have, if you have two numbers, let's say 1 5 8 9 12, they have to be in sorted order. If you have two values, two I mean ranges, where the elements are placed in sorted order, 3 4 3 4 7 10 11. In this case, merging process, what happens is it picks the first element of first range and first second range, compares, and then whichever is small it places in the first position of the resulting array or resulting list or resulting container. And then whatever it I mean, if this picks from this range, then it I mean, the focus moves to the next element, but since it was not picked from the second range, focus will remain in the same. So it will compare 3 with 5. Then since 3 is smaller than 5, then it places it here. And then focus is between 5 and 4, compares, and 4 is smaller and 4 is placed here. Now comparison happens between 5 and 7. Now 5 happens to be smaller, so 5 is placed here. And then comparison happens between because 5 is already gone, so it moves to 8 and 7 is smaller, so 7 is placed. And then now the elements of interest, 8 and 10. So out of 8 and 10, 8 is smaller, so 8 goes here. Then focus switches here to 9 and 10. 9 is smaller, 9 goes here. And then there's a comparison between, let's say, 12 and 10. 10 is smaller, 10. And then there's a comparison between 12 and 11, and then 12. So this is the process how the merging takes place. Okay, so we need to have the elements in sorted order. So maybe I can create a two vectors for this specific purpose. Person vector 1 and person vector 2, and in one vector, in first vector, I actually want to maybe for int I equals to 0, I less than persons dot size divided by 2, I plus plus, and insert these elements to pb1 dot push back I, and the rest of the element I want to push. I want to be pushing another for int I equals to divided by 2 to I less than size I plus plus, and the other elements pb2 dot push back I. So now we have the two containers. you can see what is in the container. Print C pb1, print C pb2. So I think let me go back. I should have inserted new line character just to see, just to distinguish them. So these are the content, right? So if you look from the perspective of this the length of the string, they are already sorted. But if, for example, if I want to do sorting with respect to the s, then you need to have sorting. In general, you need to have sorting first. So you have to make sure that they are in sorted order. In other words, if I want to merge this algorithm and consider sorting with respect to the length of the names, then I can directly use merge here. I can just merge these two arrays. But if I want to be sorted with respect to, let's say, s, then I want to do sorting again. Sort pb1 dot begin, pb1 dot end, and then I want to sort with respect to s. So I have lambda expression. I discussed in the previous sorting exercise that it receives two things here. Maybe copy this lambda expression and put it there, and make changes. I want to sort with respect to s. And I do the same for the another container, pb2. And then after that we want to see what happens to these two containers. Oh, I think I forgot to delete name as well. So here, remove name, now you can see this previously it was not sorted 23, 29, 31. Now it is 23, 24, 25, 29, 31 sorted with respect to the s, and the second 25, 25, 32, 36, 22. So now 22, 25, 25. So it is sorted. Now we can apply merge. So the way you want to apply merging is, let me try to reuse the list container that I had used before. This is a list. I'm not sure where this is used. Maybe this is not used anywhere, so I can make use of this list container to store the merged data. Like in my discussion, I had two ranges, and then the merged version is this one. I want to store in different container. So just to make sure that if for example, if plist has been used, then I want to clear it, and std merge, and here you want to provide this pb1 begin to end, and and two ranges. And then where you want to insert, you can use like we did before, back inserter, plist, and then we want to merge with respect to the s. I mean, the condition for merging should be look similar to this one, the way we have used the criteria we have used for sorting. So maybe I think I can just copy and paste this lambda expression. So we have, okay, sounds good. So and after that we can print c plist merge person. So you can see this has been merged because in if you compare this to um, this is a smaller in terms of s, so this goes first, and then these two are compared, and then after that 23 goes here, and then 24 and 25 compare. 24 goes here, and then 25 goes here, and another 25 goes here, right? So I mean, this is actually merged version of this two I mean, you can call range or two containers. You can consider merging with respect to, let's say, sorting and merging with respect to different criteria, including the name, alphabetical order of the name, or the length of the characters in the name, or some other criteria you can think of.